Okay, the last wee section of notes is called, it's not focused in very well there. It's called Standard Patterns. That's better. Okay, so I'm going to run through a few things here. So the first one I've got is 1 over 3 minus 2x squared. If I see that, it's a bracket. So I'd bring that up as a minus 2. If I see this one, the square root in the bottom line, I also see that as a bracket to the power of a half. I'd bring that up to minus a half. I'm just going to jump down, see it halfway down your page. If I see this, I can't bring it up. That's going to be a log 1. Right, so let's see how we do these. Okay, so I know this is going to be log. Right, do you remember the key? You have to have the derivative in front. The derivative of that is a minus 2. So you must have a minus 2 in front of your bracket. So balance outside with minus a half. Now I'm good to go. Add 1 to the bracket, divide by it, and remember the derivative disappears. And don't forget your c. So we just tidy that up. So it's minus, and a minus is plus, 1 over 2. This here can pop back in the bottom line. And you're done. This one here is a bracket. So I must have the derivative in front. The derivative is a minus 2. So it's 3 minus 2x minus a half dx. I just pop that in there so I've got the balance outside. Now I'm good to go. Add 1 to the power and divide by it. And remember the derivative disappears. A half divided by a half disappears. So you've just got minus power of a half is the square root of 3 minus 2x. And don't forget your c. This is a log 1. So if you remember the log 1s, you had to have the derivative on top, the function on the bottom, and then that goes back to your log fx. I don't have the derivative on top. Derivative is a minus 2. So you pop it on top, and outside is 1 over minus 2. Now I can differentiate or integrate that. So you just log the bottom line, and if you can remember, you always put those wee modulus signs in, so you know it's always a positive answer. Okay, just looking at the top of that page, I had this one. And then straight in beneath it, I had 4 add 5x, and that was square rooted. So this is a straightforward bracket. You must have the derivative in front. And you must balance it outside. Now I'm good to integrate. So you add 1 to the power, divide by it, and the derivative disappears. Don't forget your c. So that tidies up to 4 add 5x to the 8 over 40 add c. It's a bracket, so it's the power of a half. 4 add 5x to the half. To integrate a bracket, the derivative must be in front. So the 5 and then a fifth outside. Now you're good to integrate. The derivative disappears, you add 1 to the power, and you divide by it. Dividing by a fraction seems turning upside down, so that is 2/3. So a fifth times 2/3 is 2 over 15. 4 add 5x to the 3 over 2 plus c. Okay, that brings us down now to where it says exponentials. So let's have a look at this. E to the 4x dx. To integrate that, you must have the derivative in front. The derivative is a 4, because you've just popped that in there, balance outside. And when you integrate back to your e function, the derivative disappears. And don't forget your c. Okay, this one here, example 6. Now, x squared 1 add 2x cubed a third. It's quite a cool wee one. I've got a bracket. What's the derivative of that bracket? It's going to be 6x squared. I've got x squared outside the bracket, but I don't have my 6. So you've got to balance it. Pop your 6 in and a 6th outside. Now I've got the derivative. I'm good to go. So you add 1 to the bracket. So it's 4/3 and divide by it. And don't forget your c. So that is a sixth, that's upside down, times 3/4. 1 add 2x cubed, 4 over 3 plus c. They cancel to give you 2, so half times 1/4 is 8. Now, it's quite a good wee one. One thing I was going to say, if, could you write this down in your notes? You can't ever balance with a letter. Only balance with numbers. Very, very important. So make sure you've got that. Okay, let's see now how we're going to run through these. Example 7. You've got sec squared 2x. I think I've left off the c in my notes, but it's sec squared 2x times tan cubed 2x dx. Very hard. Hopefully at this stage you are really, really, really familiar with your tan or your differentiation of trig. Remember, tan goes to sec squared. Okay, so tan goes to sec squared. See this tan? If you treat this as a bracket, okay, the derivative of that bracket, tan goes to sec squared, and then remember you need the derivative in front. Okay, it's nearly the same, isn't it? The derivative of this bracket, if you go over here, just take the times through this. So if you were asked to differentiate that, the power would go to the front, you would take one off the power, and you must have the derivative in front. So tan would go to 2, because the derivative, and then sec squared 2x. Okay, just a wee recap there on how to differentiate. Right, so the derivative of that, before I integrate, I must have the derivative in place. I've nearly got the derivative in place, so I have to put an extra 2 in there. So you balance outside by a half. Now I have got the derivative of this sitting nicely. So the derivative of that bracket. Okay. To integrate now, you add 1 to the power and divide by it. And don't forget your c. So it's tan to the power of 4, 2x, all over 8 plus c. Now I do know that is very, very tricky, that example 7. Right, what have I got going on here in example 8? It's not a bracket or anything like that, so it's going to be one of these log ones. So I need the derivative on top. Now, what does this differentiate to give me? 2x. So I need an extra 2 on top for this to work. So I have to balance outside by a half. Now I have the derivative of the bottom and the top, so I can just integrate now. I'm good to go. So you log the bottom line. And don't forget your c. Let's see what's going on in this one. So it's e to 2x. These are tricky. dx. So it's one of these ones, I've got an x function at the bottom. It's not a bracket. So I need the derivative of the bottom on the top because it's a log type one. Right, what is the derivative of that? See if you're ever finding it hard. Just go over to the side and differentiate it. Now remember how to differentiate an e? Derivative times the function. I nearly have it on top. I need an extra 2 on top, and then the derivative is there. Because I put an extra 2 in there, half outside. Now, log the bottom line, and don't forget your c. And let's compare that to the second part. 1 add e to the 2x cubed dx. It's a bracket. So bring the bottom up as a minus 3. Before you can differentiate a bracket, you must have the derivative in front. Now, if you can't do that in your head, go over to the side. The derivative of this, differentiate an e, the derivative goes in front, and then the e function. I nearly have it. So what I need to do is I need to put a 2 in front. Because I put a 2 in front, I balance outside with a half. Now I'm good to go. To integrate a bracket, you add 1 to the power, you divide by it, and the derivative disappears. Tidying that up, you get minus, and that's a quarter, and that bracket can pop down in the bottom if you want, squared. And don't forget your C. I know this is pretty tough going here, okay? So do take your time. You might need to look over this wee video a few times, and that's not a problem because I know it is tight going. Okay, so in this one, right, this does not look pleasant at all. It's one of those log type ones because it's not a bracket in the bottom row, it's just a x function. Right, so I must have the derivative on top. Okay, so let's go over to the side and see what that derivative is. That's the bottom. The derivative of that. I've nearly got it. See, if you times that by 3, I would have it. So I need to have 3 times the top line. So because I put an extra 3 in there, balance outside with a third. Now I've got the derivative of the bottom on the top, because that's 3 plus x squared, 3x squared, which is what I want. So you log the bottom line, and I had limits here to 1. Doesn't matter that we have it inside or outside. So put your 2 in. 3 times 2 is 6, add 8 is 14, minus a half log, putting in 1, is 4. I'm going to tidy this up a wee bit. That's a half log 14 minus log 4. If you subtract your logs, you can write them as a wee division. And that wee division cancels down to 7/2.